You've probably heard of VPNs and proxies as ways to disguise where computer network traffic comes from. But what are they exactly, and how do they do this? Proxies are middlemen that disguise your traffic's origin. If you send a packet, a piece of computer network traffic via one, the proxy will swap the packet's sender IP address for its own, making it look like it sent the packet instead of the original host. There are many reasons you'd want this. Web scrapers and social media managers, for instance, tend to hammer the servers they're interacting with, so use proxies to distribute that traffic between several sources so the destination doesn't think it's under attack. You may even want to check that regional locks are in place. Say if you've paid for advertising in a specific locality, or you're developing a system which does show localised content. There's also reverse proxies. Under the hood, most cloud apps are actually several different servers all working together. Having to work out which server to connect to every time you use the app just isn't practical. So reverse proxy provides a single entry point to the system and routes any incoming traffic appropriately. VPNs, on the other hand, don't just swap IP addresses, they provide entire smuggling operations. After minting a packet, your device encrypts the entire thing, puts the encrypted gunk inside another packet, and sends that packet onto the VPN server. Upon arrival, the wrapping packet is discarded and the junk decrypted, revealing the original packet whose IP address is swapped out, and then sent on its merry way. Without a VPN, your packet is likely partially encrypted. The payload, the data it's carrying, certainly, and hopefully some of the headers, the packet's metadata too. But what isn't can give a lot away, either to your ISP directly or to anyone else who's intercepting packets on your network. Now that might not be a problem, but if you capture enough packets, even heavily redacted ones, then patterns can emerge which can betray the insides of your system. How a VPN helps is by providing a single anonymous route that guarantees your original packet is never exposed to the public internet. Sure, the VPN wrapper packet can be intercepted, but all that'll ever show is that you're using a VPN, nothing about what you're using it for. And even if your original packet is intercepted as soon as it leaves the VPN server, it'll be one of many and there's no evidence it came from you. But how do you know if your VPN's reading your traffic? And what happens if it's served a search warrant? Well, many VPNs, and proxies too, offer zero logs policies, which wipe any trace of your traffic as soon as they're done handling it. This process of encryption and wrapping is called tunneling. So called because it's as if your packet went underground at your device and popped out the other end at the VPN server. And this is why you've likely used them at work. VPNs, or virtual private networks to give them their full name, are networks that use tunneling to let you remotely connect to them. And once virtually connected, your device can act as if it's actually in the network. This means servers within your company network can be sealed off from the public internet, accessible only to those inside, so they're less exposed to potential attackers. And because your traffic is tunnelled, no information about what you're doing is visible, so you can work from home, a public library, a cafe, or anywhere else without having to think about whether the network you're on is actually secure. Tunnels or not, because both VPNs and proxies mask your IP address, they can be used to bypass content logs. This works because your IP address indicates which country you're in. Each country has blocks of IP addresses that only people in that country can use, so if your traffic's address has been swapped out for one in another country, the destination server will think it came from there, and treat it accordingly. Assuming it doesn't cotton on, of course. Unless your provider changes the IP address of their servers regularly, suspicious IP addresses will eventually be noticed and blocked, which is why your proxy or VPN might suddenly stop working. In summary, both VPNs and proxy servers disguise the origin of computer network traffic by swapping the sender IP addresses on packets for their own. But really, the similarity ends there. Proxies are IP swap shops, good for pretending you're somewhere you're not, providing single entry points to back-end infrastructure, and making your device not look like it's staging a DOS attack. VPNs, on the other hand, provide tunnels. They smuggle traffic from one network to another, making it seem like the original sender was part of the destination network all along. When doing this, they encrypt entire packets, making them totally unreadable until they get to their destination network. So if anyone did intercept your packets, including your ISP, they'd be none the wiser to your internet activity. Because they both mask IP addresses, VPNs and proxies are both ways to bypass regional content restrictions, as well as government-imposed ones. Which, let's face it, is probably why you're watching this video. But maybe the desire to do that is a sign it's time to go outside or read a book. At the very least, you won't be risking blindness and hairy palms.